Section 10.2 is on polygons and quadrilaterals. Here's a diagram that shows pictures of what's a polygon, what's a regular polygon, and what's not a polygon. So the definition for polygon is a closed plane whose sides are segments that intersect only at their endpoints. Meaning here, because those intersect, it can't be considered a polygon. And for this one here, because there's a gap in it, it's also not a polygon. And in this case, since there's a curved edge, it's not a polygon. So it needs to have straight sides, and they can only intersect at the endpoints, like here. A regular polygon means that each side is the same length, and that each angle has the same measure. So if you look here, you can see that here we have a square as an example. We have a pentagon because there's 5 sides, and we also have a hexagon because there's 6 sides. But every angle within each of these regular polygons is equal, and so are the side lengths equal. So that's what it means with a regular. Where in this case, the polygon over here is a triangle. These angles are not the same. Each one is different. Now this star over here is actually a regular polygon as well, likely. Actually, no, that's just a polygon because it doesn't go, because it has this part that goes in and out. It has angles that are a different size. This angle is different from this angle. But that's what we're going to be focusing on in addition to quadrilaterals. There's also 2 other vocabulary words we'll have to use in this section. It's convex and concave. So you may have used these before, but a polygon that is convex is considered convex if a segment joining any 2 interior points, so anywhere within an object from 2 different points, it's going to lie completely within the polygon. So it's impossible to draw a line that's within any 2 points and have it go outside. A concave is not the case because you can draw a line that goes from one point in the shape to another that extends outside. So here we can draw some that are good, but other times we may cross those lines. So that would be concave. So here's a table that goes over the number of sides and the name of a polygon. So we have a pentagon, which is 5, a hexagon, which is 6, a heptagon, which is 7, and an octagon, which is 8. And then we have something called an n-gon, which is for n, which n can be any number. So say it had 10 sides, you would put a 10-gon. Or a 20-gon, or an 11-gon. You just write it that way. So take a second below and tell whether the figure is a polygon or not. And if it is, classify it and tell us whether it's a concave or convex. If not, explain why. So you're going to give it one of these polygon names, and you're going to say whether it is a polygon or if it's concave or convex. Press pause now. So for the first one, you should have written no because there's a curved edge or a curved portion of this shape. For the second one, you should be able to see that there's 1, 2, 3, 4, 5 sides. So it's a pentagon. And they look to be the same with the angles. So you could say that it's a regular pentagon. But let's look. Can we draw a line anywhere within without going outside? Yes. So it's considered concave or convex. Which is it? It's going to be convex. The way I like to think about this is concave kind of looks like a cave, and there'd be a portion going in to the object. So in the next case, we can again look at it, and this one's definitely a convex. Or sorry, a concave, because look, it has this cave-like portion where we could go outside of it when we draw these straight lines in between. So we have concave, so it looks like a cave. And then how many sides? 1, 2, 3, 4, 5, 6, 7. So it's a heptagon. So now we're going to move on to the quadrilateral portion of the section and going over some words in special quadrilaterals and the names that they have. So these are based on if they have parallel or congruent sides, and it would be nice if you put a table into your notebook that's similar to this. So we have the quadrilateral and the diagram of the quadrilateral. So a trapezoid is a quadrilateral with exactly one pair of parallel sides, which you can see I indicated with the blue little arrows opposite each other. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So here you can see that instead of having these two edges going out away, which aren't parallel, now we do have two parallel edges on the other side as well. Oops. Let's undo that. So the next one's a rhombus, which is a parallelogram. So the one above here, but it has 4 congruent sides. So now they're parallel, the sides, and congruent, meaning the same length. A rectangle, which you should be familiar with, is a parallelogram because it has 4 sides, but they all have right angles. So these are still parallel to one another, but now we have 4 right angles in it. And a square is a parallelogram with 4 right angles and 4 congruent sides. So I would take a second and put this into your notebook to help you have a key for when we get to the quiz. So go ahead and take a minute and see if you can classify these quadrilaterals based on what we learned on the previous slide with those special names. Press pause now. So the first has 2 parallel sides. So this would be a parallelogram because both pairs of opposite sides are parallel. The second, we have 2 sets of parallel sides, and each of them is a right angle. So in this case, it's a parallelogram with 4 right angles, so we call it a rectangle. So just like we learned with triangles, that every triangle has 180 degrees, every quadrilateral, quad meaning there's 4 sides, angles always adds up to equal 360. So in this case below, we have this weird looking quadrilateral, and we can see that one of the angles is 90, it's a right angle. We have an angle that's 68 degrees, and we have an angle that's x, and we have another angle that's equal to 2x plus 1. And we want to figure out what are these unknown angle measurements. We don't know the number for 2 of them, but we know something about it, and we know what they're going to add up to equal. So we want to set up our equation initially to be adding up all these angles and setting it equal to 360 degrees, because we know that every quadrilateral is going to have 360 degrees in it. So go ahead and press pause now and try this on your own to see if you can solve for x, and then in turn tell me what the angles of the 2 unknowns are. So if we combine the like terms, we have 3 x's, because you remember anytime you have x alone, it's as if there's a 1 in front. So we combine our 3 x's, plus we can add 1 plus 90 plus 68, which is 159, equals 360 degrees. We can then go ahead and solve for it. So we subtract 159 from each side, leaving us with 3x equals 201, and then x equals 67 degrees. So we can go back and say this angle here is 67 degrees. And the second angle is going to be equal to 2 times 67 plus 1, which is going to equal 135. So, and we should be able to go back now and add up all 4 of the angles and make sure that it's equal to 360. So use your calculator. 135 plus 67 plus 68 plus 90. And yes, it does equal 360. So that's how we can find the unknown angle measure in a quadrilateral. So try this problem on your own and bring it to class tomorrow for discussion. I want you to find the unknown value of y and classify the quadrilateral with its proper name. So press pause now and work on this on your own. Okay, and that concludes this video lesson.